Alright, today we're going to start chapter 2, so we're going to look at section 2.1, and we're going to look at polynomials and the quadratic function. So we want to understand the definition of a polynomial and look at a quadratic function. All of this should be review. It's just going to be some definitions and a few brief examples. Okay, so first let's define a polynomial function. So we're going to say let n be a non-negative integer and a sub n minus 1 and so on down to a sub 1 and a sub 0 be real numbers where a sub n does not equal 0. Then, if we have this scenario, f of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus so on a sub 1 times x plus a sub 0 is a polynomial function. With degree n. So n represents the degree of the polynomial function. The a sub n minus 1, and so on, those are all coefficients of each term for the polynomial function. So this is our standard form of a polynomial function. The thing to note is in standard form, if we have a polynomial function in standard form, the degree is in descending order. So that means that n is the largest exponent on any x value. That's why it's the degree of the polynomial. We have many types of polynomials. It can be any degree we want. You know, a linear function is a polynomial of degree 1. A constant function is a polynomial of degree 0. A quadratic function, which we're going to focus on next, is a polynomial of degree 2. So now let's look at the quadratic function. So if we want to define a quadratic function, we're going to say let a, b, and c be real numbers where a does not equal 0. It's okay if b and c do. Then f of x equals ax squared plus bx plus c is a quadratic function. So note this is a polynomial of degree 2. What is the shape of this function, of a quadratic function? Well, that's going to be a parabola. Okay, we understand that. Okay, so now let's focus a little bit more on the quadratic function. So what is the standard form of a quadratic function? So the standard form of a quadratic function is also sometimes called vertex form. and that's if the function is written as f of x equals a times x minus h quantity squared plus k. So this a here is the same a that we had in the ax squared plus bx plus c. But now notice we don't have the b and c, we have an h and k. And this form is nice because h and k tell us a lot about the quadratic function. They tell us the vertex. So the vertex, which is also called the min or the max, depending on which way the parabola opens, is the point hk. Also notice that if we think back to our transformations, the a represents vertical stretch or shrink, and it would also relate to a reflection, h is going to be a horizontal shift, and k would be a vertical shift. We also have what's called an axis of symmetry. Because it's a parabola, we know it's symmetrical. And the axis of symmetry is going to be the vertical line x equals h. Okay, so how do we convert from the ax squared plus bx plus c form into the standard form? Well, we complete the square. So I want you to pause the video and find the vertex, the intercepts, and sketch the quadratic function of f of x equals 2x squared plus 4x minus 7. So pause the video and unpause it when you're ready to check your answer. Okay, so I completed the square first. I know it didn't say put this in standard form, but part of this was I wanted you to practice that. So to complete the square, remember we need a leading coefficient of 1. So I divided everything by 2, and I also brought the 7 over to the other side to isolate the x squared in the x term. So that's how I ended up with the f of x over 2 plus 7 over 2 on this side. Now here I had x squared plus 2x, so to complete the square I take half of the middle term and square it, so half of 2 is 1, 1 squared is 1, add 1 to both sides. 7 over 2 plus 1 is 9 over 2, and then this is my perfect square trinomial, so that factors into x plus 1 quantity squared. Now get the f of x by itself again, so subtract the 9 over 2 back to the right hand side of the equation, and then multiply everything by 2 to get my standard form of f of x equals 2 times the quantity x plus 1 squared minus 9. Now this is my standard form, so it's nice. I can see right away my vertex is -1, -9, because this is x plus 1, and that's a minus 9. The axis of symmetry is the line x equals -1. Now I also asked you to find the intercepts. So how do we find x and y intercepts? Well, y intercepts we find by just plugging in 0 for x, remember? So that's actually easier to get from the original function. If I make this 0 and this 0, then I get -7. So I go down here, I know my y-intercept is 0, -7. Now the x-intercept is actually easier to get from the standard form of the quadratic function. The reason being is that we've already completed the square. So if I take the standard form here and I set it equal to 0, I'm going to add 9, divide by 2, and then I take the square root of both sides, so the square root of 9 over 2 is plus or minus 3 over root 2. I want to rationalize this. We always want to rationalize unless it's a variable in the denominator. If it's a number, we want to rationalize. Variables, we don't need to. So I end up with x equals -1 plus or minus 3 root 2 over 2. So my two x-intercepts are -1 plus 3 root 2 over 2, comma 0, and -1 minus 3 root 2 over 2, comma 0. Then my last step, and just again to point out, so had we used the ax squared plus bx plus c form to find the x-intercepts, we would have needed to complete the square or use the quadratic formula anyway. So since we already did that, that's why the standard form was actually easier. So then now to graph this, I just wanted to plot the points that I know and draw a general shape of the graph. So I know the vertex is -1, -9. I know I have a y-intercept of -7. And then my x-intercepts, I'm approximating those. This is like 1 point something, and this is -3 point something. So if I do -1 plus 2 root 3 over 2, and -1 minus 2 root 3 over 2, those are the values I'm going to get. So just to recap, the standard form of a polynomial function is f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, and then so on, a sub 1 x plus a sub 0. And then our standard form of a quadratic function, which is a specific type of polynomial function, is, in this case I'm calling it g of x, so that we don't get confused with the f of x already, equals a times the quantity x minus h squared plus k, where hk is the vertex, and x equals h is the line of symmetry. If you notice, I deleted what was written as homework here. That was incorrect, so if you wrote that down, ignore it.